Okay, class, welcome back. And today we are going to finish chapter 1. And this is going to be section 8 on absolute value equations and inequalities. So these are going to be equations and inequalities dealing with absolute value functions. Okay, so we're going to talk about basic concepts, the absolute value equations, absolute value inequalities, and then there are some special cases and also absolute value models for distance and tolerance. So the absolute value of a number, a, gives the distance from a to 0 on a number line. So basically it's like the displacement, how far a given number is from 0. So in this case, if we're looking at -3, what's the distance from 0? It is 3 units. Okay. What is the distance of this number 3 from 0? It's 3. Okay. So regardless of whether it's a negative number or a positive number, the distance is always positive. So the absolute value given by the symbol, the two vertical bars, is 3. So the absolute value of x is 3 can be solved by finding all the real numbers at a distance of 3 units from 0. So in this case, there are two values that satisfy that. So 3 and -3. Okay, because the absolute value of 3 is 3, and the absolute value of -3 is also 3. And so the solution set is plus or minus 3. Now, if we look at the three cases here, case 1, the absolute value of k, and in this case here, when we write this, what this means is that x equals k, or x equals -k. And so in this case, we have 2 points. Okay, and the solution set is k plus or minus k. Okay, now this is the equation. Now, what if we have an inequality? This is saying that the absolute value of x is less than k. Okay, so if it's less than k, we're saying that x is either less than k or greater than -k, because we have to multiply both sides by -1. Okay, so that means we have to flip the inequality. So we get this result. So the absolute value of x being less than k is the same as x being between k and -k, which is given by this graph, right? So we're all the values that are in between k and -k. Okay. Now, if it's greater than, so the absolute value of x is greater than k, that means we're saying it's either greater than k or less than -k. And so now we get this area, this graph, right? So basically it's everything else except for the middle. Okay? So up here it's just the middle when it's less than. When it's greater than, then it's everything except for the middle. Okay? And so we also, using interval notation, we can write it in this way. So make sure you familiarize yourself. So now in cases 2 and 3, the strict inequality can also be replaced by the non-strict form, and you get the similar results. Okay. Additionally, if an absolute value equation takes the form of the absolute value of A is equal to the absolute value of B, then A and B must be equal in value, or they must have opposite values. Okay. Thus, the equivalent form of this is A equals B, or A equals -B. Okay. So this is another thing that you want to make sure you understand. Okay. So let's look at this. So let's solve this thing. Okay, so we're going to use the definition of the absolute value to help us solve these. So for the given expression, we're saying that the absolute value is 12. The absolute value of that expression is 12. So that means the value of that thing is either equal to 12 or equal to negative 12. Okay, so this is the first case. Okay, and so we say this. So 5 minus 3x is equal to 12, or 5 minus 3x is equal to negative 12. And so then we have to solve each of these independently. Okay, and we end up with x is equal to negative 7/3, or x is equal to positive 17/3. Okay, and so those are the solutions. Either one of those solutions will work. Okay, so check by substituting them in the original absolute value equation. Always make sure you check your answer just to make sure that you didn't make a mistake somewhere, okay, and to verify that they are indeed in the solution set. And so this would be the solution set. Now let's solve this one. So now we've got two absolute value expressions that are equal to each other. So we're going to use that note. We're going to use that the result that we were talking about earlier, a few moments ago. So we're going to say this is going to equal to this, or this is going to equal to the opposite of this if we drop the absolute value sign. So this is what we get. So using that result, we can say these two are going to be equal to each other, or this is going to equal to the opposite of this. And then now we're going to solve each of these equations for x independently. Okay? And so if you solve for these, you get x is equal to 3, or x is equal to negative 3/5. And so there's the solution set. Okay, so now what about this one here? Here we have the absolute value of 2x plus 1 is less than 7. Okay, so that means that 2x plus 1 is less than 7, or 2x plus 1 is greater than negative 7. Okay, and so we get this result. Okay, and so now we're going to solve this three-part inequality, which we've done before. So now we're going to subtract 1 from both sides, and then we're going to divide each part by 2, and we get this. So we get x is greater than negative 4 and less than 3. And so we get this solution set here. Negative 4, the interval from negative 4 to 3. Okay, now we're going to do greater than. So now it's greater than. So now what does this mean? It means that 2x plus 1 is greater than 7, or 2x plus 1 is less than negative 7. So this is going to be case 3. So now we have either one of these. So now we're going to solve each of these inequalities separately. And we get x is less than negative 4, or x is greater than 3. And so this is where we're going to have to use the union of the two intervals. Okay, so we're going to have everything from negative 4 to negative infinity, union with everything from 3 to positive infinity. Okay, so now what about this one? Well, the first thing we're going to have to do is get the absolute value function, the absolute value term by itself. So we need to isolate it on one side of the inequality. So here we're going to add 1 to both sides. And so if we do that, we just get the absolute value of 2 minus 7x is greater than 5. And so now we can use what we know from the cases, right? So what does this mean? See, and I don't memorize cases. I just say, hey, what does this mean? It means that 2 minus 7x is greater than 5, or 2 minus 7x is less than negative 5. Okay? And so we get this. And so now we solve both of them. and we get that x is greater than 1 or x is less than negative 3/7. So again, this is case 3, so greater than 1 or less than negative 3/7. So that's going to be a union of two sets again. So we're going to have this set union with this set. And this is the solution set for the inequality. Okay, now solve each equation or inequality. So here we go. So now what are we going to do? We're going to do the same thing. So this is going to, now all we're doing is this is greater than or equal to. So we're going to do the same thing. This means that 2 minus 5x is greater than or equal to negative 4, or 2 minus 5x is going to be less than or equal to 4. Okay? So, since the absolute value of a number is always non-negative, right? Since the absolute value of a number is always non-negative, see that's negative, the inequality is always true, right? Because this absolute value has to be positive. So this will always be greater than or equal to negative 4 for all values of x. So that means this solution set is all real numbers. Now what about this one? Well, here we have the absolute value of 4x minus 7 is less than negative 3. Well, can this ever be true? And the answer is no. Because remember, for the same reason up here, right, where this is greater than or equal to, the same reason this is always true is the same reason that this is always going to be false. Because this will always be positive, so no, there will be no value of x that will make this less than negative 3. So the solution would be the empty set. Okay, what about this one? Well, here is absolute value of a value x, but it's equal to 0. So what happens here? Because we're going to do 5x plus 15 is equal to 0, or it's going to equal to negative 0. Well, there's no such thing as a negative 0. Okay? So in this case, the absolute value signs don't matter. It's equivalent to just dropping the absolute value signs. So in this case, it'd just be negative 3 in the solution set. So now in this case, we're going to write each statement using an absolute value inequality. So let's say we say k is no less than 5 units from 8. So k is no less than 5 units from 8. So that means it's going to be 5 or more units from the number 8. So k is 5 or more units from the number 8. Okay, so now since the distance from k to 8, right? So since the distance from k to 8 is written with the absolute value sign, or we could do this, right? So k minus 8 or 8 minus k is no less than 5, that means greater than or equal to, the distance is greater than or equal to 5. So this can be written as this. So we're saying the absolute value of k minus 8 is less than or equal to 5, or we could write the absolute value of k, or excuse me, 8 minus k. So now what about this one? This one says n is within 0.0001 unit of 6. Okay, so some number n is within 0.001 unit of 6. So here we know that the distance from n to 6 is what? Within is like less than. So less than 0.001. Okay, so this would be an absolute value, right? So we're going to say the absolute value of n minus 6, or 6 minus n, is less than 0.001. Now, in quality control situations such as filling bottles on an assembly line, we often wish to keep the difference between two quantities within some predetermined amount. This is called the tolerance. Okay, this is for quality control or quality assurance. So tolerance is very important, because if you're out of tolerance, that means things aren't good. There's a problem with the process. So if you're within tolerance, then the process is good. Okay, then you're doing good quality. If you're out of tolerance, then quality is going down. So in this case here, it says suppose that y equals 2x plus 1, and we want y to be within 0.01 units of 4. For what values of x will this be true? Okay, so we want y to be within 0.01 unit of 4. Okay, so y, which is equal to this, we want this to be, so if we subtract 4, right, we want it to be within that value to be within 0.01. Okay, so how would we set this up? Well, we want y minus 4, just like we did before, the absolute value of y minus 4 to be less than 0.01. Now we're just going to stick in y, and now we're going to simplify this. Okay, now it becomes something that we've seen before. Okay, and so this becomes 2x plus what? Negative 3 is less than 0.01. And so now we can solve this like this. And so now we're going to solve for x. So now we're going to add 3 to both sides. And then we're going to divide both sides by 2. And look at this. Here's our tolerances. So x has to be within these two measurements in order for x to be within 0.01 of 4. Okay? So reversing these steps shows that keeping x inside this interval will ensure that the difference between y and 4 will be within this amount. Okay? Okay, so that is the end of this section and the end of this chapter. And please, I hope that you are keeping up with the videos, asking questions, taking notes, write down your questions. If you get stuck on something, bring those to class, or email me, and I'll make sure I cover them in class the next class period. So until then, you have a great day. Remember, that's flashing, don't use it. When I'm doing a video, don't use it. Wait till I'm done. Okay, or get my attention so I can pause it, because it sounds like somebody going to the bathroom.